Energy of a particle performing linear SHM. Today we discuss the kinetic energy in simple harmonic motion, potential energy of particle in simple harmonic motion, and total energy of particle in linear simple harmonic motion. Now consider a particle performing a linear SHM along a path n and towards the mean position O. We consider the displacement of particle along the path n, and O is the mean position, and consider a particle displaced at distance x and moves at point P. See, very small time interval, or in time t, the particle moves from O to P. There is small displacement x. Let small m be the mass of particle, and this particle perform linear SHM along a path mn along path mn, whose center or this particle moves along path mn, and this displacement is towards the center, that is mean position O. Hence, we calculate the kinetic energy of that particle. The kinetic energy KE or EK. EK gives the kinetic energy of particle, and this kinetic energy is given as EK is equal to half m square. But we know that the velocity in uniform circular motion, in previous lecture we calculate the velocity v is equal to omega under root a square minus x square, where a means amplitude. This distance O n or OM is nothing but the amplitude of particle. The kinetic energy Ek is equal to half mu square, but the velocity in simple harmonic motion is v is equal to omega under root a square minus x square. Hence, v square is equal to omega square. त्याचा वर्गमूळ निघून जाईल a square minus x square. Now, using this value, kinetic energy become half m omega square into bracket a square minus x square. This equation gives, that is Ek is equal to half m omega square into bracket a square minus a square. This equation gives the kinetic energy in simple harmonic motion, or this can be written as upon differential equation of SHM मध्ये घेतले पहा की k upon m is equal to omega square. Hence, this gives values of k is m omega square. Instead of m omega square, we put value k. Therefore, Ek, that is kinetic energy K is equal to half K A square minus x square. This is another formula of kinetic energy. 1/2 K under root, into bracket A square minus x square, where K is force constant. This is also kinetic energy. This is, then we can calculate potential energy in simple harmonic motion. The potential energy in case of simple harmonic motion, the potential energy in the form of work done. When the particle is moves or oscillate along path m to n, and the magnitude of that force of that particle is moves towards the mid position or center of that path, and we know that the magnitude of force is directly proportional to displacement. That is, F is directly proportional to x, or F is equal to minus kx, where minus sign indicate that force and displacement are in opposite direction, and k is called force constant. Now, due to this displacement of particle, work is done, and this work done, dw is equal to minus F into dx. Using this value, therefore dw is equal to minus kx into dx, or this is equal to kx into dx. This is work done. Now we find out total work done, taking integration of both sides. Integration dw is equal to integration kx into dx. Integration dw means total work done, k is constant, integration x into dx, w is equal to k, integration x is x square upon 2, or the work done is nothing but w is equal to half kx square. But this total work done in the form of potential energy, therefore potential energy Pe or Ep is equal to half kx square. This equation gives the potential energy in simple harmonic motion, that is Ep is equal to half kx square, or this can be written as half m omega square x square. Put values of k is m omega square, then we get potential energy Ep is equal to half kx square, or this can be written as half m omega square x square. Now we calculate the total energy. Total energy in SHM is equal to Ek plus E. Therefore, put values of Ek, that is half m omega square a square minus x square, and value of potential energy, that is half m omega square x square. अपन बोल करो क्यों हाफ m ओमेगा स्क्वायर a स्क्वायर माइनस हाफ m ओमेगा स्क्वायर x स्क्वायर सेपरेट लिहून घेतला प्लस हाफ m ओमेगा स्क्वायर x स्क्वायर. इथं माइनस इथं प्लस, minus plus cancel, we get total energy E is equal to half m omega square a square. This is the total energy in linear simple harmonic motion, that is E is equal to half m omega square a square, or this can be written as in the form of force constant, that is half k a square. This is the total energy in simple harmonic motion. In simple harmonic motion, we calculate kinetic energy, potential energy, and total energy. Now, this total energy, that is E, is equal to half m omega square a square. But omega is equal to 2 pi n. Therefore, E is equal to half m 4 pi square n square a square. Where E means total energy in simple harmonic motion, 1/2 is constant, m means mass of particle, 4 pi is constant, n means frequency of particle, and a means amplitude of particle. From this equation, it is clear that number 1, this energy is directly proportional to mass of particle. The total energy of particle in SHM is directly proportional to mass of particle. Number 2, from this equation it is clear that this energy is inversely proportional to square of frequency. Energy, total energy in simple harmonic motion is directly proportional to square of frequency. Number 3, this energy is directly proportional to square of amplitude. The total energy in SHM, the total energy of particle in SHM is directly proportional to square of amplitude. And number 4, we know that omega is equal to 2 pi upon t, where t means period, and this energy is inversely proportional to square of period. That is, the total energy in simple harmonic motion, that is E, is inversely proportional to square of period. This is the observations, or we observe this energy depends upon these 4 factors, that is mass, frequency, amplitude, and period. This 1, 2, 3, the energy is directly proportional to mass, directly proportional to square of frequency, and directly proportional to square of amplitude, but the energy is inversely proportional to square of period. Now we find out the variation of kinetic energy, potential energy, and total energy, or we say that the variation of displacement versus energy. This y-axis gives the energy, and this x-axis is the displacement of particle. This is positive x-axis, negative x-axis. Then this energy the nature of this curve is acts as a parabola is the potential energy. At that point, the curve of kinetic energy and potential energy, at that point, the potential energy is equal to kinetic energy, and also the kinetic energy is equal to potential energy. This gives the total energy. This graph shows the variation of kinetic energy and potential energy, or this graph is displacement versus energy. The nature of graph is very similar to parabola.